Okay, friends, we're going to take a look at our third lesson in related rates chapter. Right now, we're going to take a pause before we begin related rates because there's certain prerequisite skills you need to be masters of, and those topics would be Pythagoras and similar triangles, as well as drawing and modeling contextual situations. So this chapter here is very, very focused on your ability to draw and model contextual situations well. And the simplest way I can describe a great model or a great uh, picture for situational context is if we could remove the word problem and look only at your drawing. And if you're able to answer the question only from the drawing, then you have drawn it well. So that's how good we need you to be and how good you're going to be. So first off, today, really, you're going to be doing this a ton. This is 1B, so being able to make connections between ideas using models, graphs, pictures, terminologies, words, numbers, and so on. And of course, explain and justify is something that you've been working on many times throughout this course, and will continue to do so. Also, many of the reasoning competencies, in particular modeling, will be very helpful, as well as solving and your ability to visualize and get those ideas out and then use those to solve problems. So that's what we're going to be looking at. The content, as well as the curricular competency, is to draw pictures meaningful, to represent problems in meaningful ways, and meaningful meaning that other people could look at your drawings and use your drawings to solve problems. So here we go. So there's going to be some tricky problems today. First, I really recommend that you look at these. These are some great proofs of the Pythagorean theorem, but I'm going to assume, I am assuming that all of us are very comfortable with a squared plus b squared equals c squared. So I am assuming that. You can watch these clips on your own time to take a look at the proofs. And they're nice to watch, and I encourage you to do that. Okay, the similarity was a concept we looked at in grade 9, and it'll be very easy for us to forget what similarity means. And so similarity means that it's proportional, basically same shape, different size. So all the corresponding angles would be equivalent. So this angle, all these angles at the top here would be the same size angle, but these side lengths would be proportionally the same. So there'd be a multiplier to all the sides, and that's where it came. Let's see if this Desmos help. Yeah, this will help a little bit. So these triangles are similar, and if they're similar, these guys here, if I put that guy right in there, you could see that, it's always going to fit in. Those angles would always be the same. So I could play around with the size of that. I could move this around here, and if I put that in there, you can see that this is always going to be parallel. And if we pulled this guy out, I don't know if I can move that. Let's see if I did that. How do I make this bigger? Oh, maybe it's this one that I pulled down. Oh yeah. So I could, obviously, if I move them down, they're ultimately going to be the same size, which they are, and you can see that. So similar triangles, we can count on them being proportionally the same size, meaning that there's the same multiplier from this side to this side as there is from this side to this side. Okay, now this seems simple enough. Well, let's just make sure. So these two triangles are similar because the corresponding angles are the same. So if this side is 4 and this is 8, we should be able to figure out this one because we know that side lengths are proportional. So if this side was multiplied by 2, then so was this one, and that's why we know that this side length here is 12, and there you go. Now this seems pretty simple, and this is going to be really easy, right? Honestly, the reason I'm going over this is because there's one section that causes such trouble in grade 12 is our knowledge of similar triangles. So let's be careful, let's stay safe, and if we do fall, let's get back up. Alrighty. So this is a great video clip to take a look at just for how we can be tricked by similar polygons, and so I'll get you to take a look at that on your own time. This is another one that's just classic to look at. Notice that it's a 13 by height of 5 and width of 13, and both these triangles look exactly the same. However, something's going on here. Did you catch that? And so I ask you to pause the video and ask yourself, why is that? How is this happening? You need to notice, you need to wonder, you need to be careful. Where did that little square come from? Okay, that's an aside, just to let you know that you need to be paying attention. You need to be working your curricular competencies. You need to be noticing, wondering. You're going to need to be curious. You're going to need to be creative here as we progress. Okay, so first things first, how long is the diagonal of this cube? So that's the first question. It's a 3D cube. And so drawing this is going to be very, very important. Please notice that the units here would be 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and so on. And so please pause the video and give it your best go. So this is clearly a tricky question. What I'd like to do here is draw it. I'm drawing this with a mouse, so good news for you is that this is going to go pretty slow. So this distance here is 5, this distance here is 5, and this distance here is 5. What we're trying to do is find this distance right there, okay? And, this is a tricky question. I'm going to kind of give the illusion that this is, in fact, 3D. Okay. Another thing that I'd like to do here, I've done this a bunch of times. This would not be obvious to you to do, but can you guys just see that basically, wrong color. Let's get some green in here. So why is that not changing colors? That is now green. Okay, so what I'm going to do is obviously what I need to do first is sort of help myself visualize this. And this is easier said than done. But, oh gosh, I just erased it all. Shoot. I have to start that again. Okay, here we go. Yes, that is me sighing. Okay, so that's 5 by 5 by 5. And what we're trying to do is figure out the distance from here to there. And that's a diagonal. It might be hard to visualize that. Okay, so I'm going to try to give the illusion of the 3D there. So there we go. This is not my best work. What I'm going to do is, can you visualize this is the hypotenuse of this 5 by 5. So if I were to draw that, we'd have a 5 by 5. And this right here would be the square root of 5 squared plus 5 squared. And that's what that distance there would be. So it would be the square root of 50 approximately, which is going to be about 7-ish. Okay. Notice that this diagonal right here, if I draw this diagonal right here, can you imagine this green face here? I'm going to draw it like so. Right there. That guy right here is that blue line right there. So this piece right here is root 50, right? And this distance right here is 5. And we're trying to find that diagonal. So all we need to do to find that distance there would be, of course, go, if we call this D, that would just be, 50 squared plus 5 squared equals D squared. So that's going to be 50, square root of 50 squared is 50, plus that is going to be 75 equals D squared. So if we square rooted that, it would be the square root of 75. Okay, so there you go. That's the equation for it. It might be hard to visualize that, but if we can imagine that this face here is sort of that diagonal sheet, and since those are all going to be right angles, we can count on that working out just perfectly for us. So there we go. We're going to leave that. Now let's look at the next warm-up question. Oh, that was the solution there, the square root of 75. Now, this next one, I'm going to ask you to create your own equation. Now, if you were in class with me, when you look for an answer, you're going to get the you wish and the figure it out. And really, you absolutely need to be able to figure this out on your own. I will provide an explanation right now, but you're not doing yourself any favors if you are not able to figure this out on your own, okay? So put the video on pause and create your own equation. Okay, so welcome back. what I'm going to do is draw like so. Okay, so this first triangle here, which I'm going to sort of shade in red here, this distance here would be c because that's the height. So this guy here, which I'm going to call, how about I call this diagonal here e? So we know that e squared would equal c squared plus c squared plus a squared. So that means that e would equal the square root of c squared plus a squared. Okay, so that's what this e here would be. And then if we were looking at this diagonal here, and let me try to draw that as best I can. Tonight this is the best I can do. Okay, so it's going to look like that. And remember, that is it's a very sad right angle. There's that diagonal that we're looking for, and this is D right here. This is B, and this is the square root of essentially a squared plus c squared. And so if we wanted to find out d squared would equal b squared plus the square root of a squared plus b squared all squared. So if we simplified that, we'd have d squared equals b squared plus c squared, and there's my little a squared. So here's your new equation. So the diagonal of a rectangular prism can be found by going a squared plus b squared plus c squared, and that's a formula we have derived, and you should be able to do that on your own without watching this clip. So if you did not solve that on your own, you need to be asking yourself how you're doing with curiosity and wonder and perseverance. That is a little formula that you should and could get on your own, and it's expected you could do that on your own. Okay, alrighty. Let's just do a quick review of triangles as well. What do you know about these two triangles? Two equal sides. Okay, so this is an isosceles triangle. These two angles here are the same. These two sides are the same. It's an isosceles triangle. This is an equilateral triangle, which means three equal sides and three equal angles. Okay, both of these triangles this triangle has one line of symmetry. This triangle has three lines of symmetry. Just for what it's worth. And yeah, so let's take a look at this one. One of the equal sides of an isosceles triangle is 41. Determine the area if the height is 9. So let's dig in. So pause the video. You should be able to solve this question on your own. So we're really practicing your perseverance, your curiosity, your wonder, your willingness to draw good pictures. And so draw this picture really well before you attempt to answer the question. Okay, so let's dig in. So here is the picture. They told us that one side length was 41, and since it's an isosceles triangle, and I think they told us that, yeah, the isosceles, and they also told us that the height was 9. And what was the question asking for? Determine the area. Okay, so as soon as we've done that, it says find the area. So somewhere we should be writing down area of a triangle. Area equals 1/2 base height, or some people like to write it as base height divided by 2. Those are equivalent. So, and we could also figure out this length here. Maybe we need that. Okay, so basically we could figure out this length from here to here, because that's 9 and that's 41. So by Pythagoras, we could figure out that this length is 40. Therefore, this whole length is 80. And when we go to solve this thing, we know that the area of a triangle equals base over 2. And there's our base, and there's our height, and divide it by 2, and you are done. Okay, so I think this drawing was pretty good. What should have been stated in the solution right from the very beginning is area equals height times base, basically, just so that we'd have that. But we knew in this, so we probably should have started with, area equals 1/2 base height, and we could have filled a part of that out already because we already knew that the height was 9. So we're really just figuring out what's the base. That would have been a better way to start this problem. So yeah, I made this PowerPoint, but I think my explanation was lacking in terms of start with what the question was, which is this, point to the base is what we're trying to find, and then use this triangle to find the base, and then we're done. Okay. All right, let's take a peek at this challenge. Okay. Show that you understand this problem by drawing a carefully labeled picture to represent this situation. Okay, so John is 1.7 meters tall. There's John way down there, and he is kind of tiny. Okay, and this building has a shadow of 104, and this building has a shadow of 239.3. And how many meters taller is building B than A? Wow, it really feels like there's not a ton of information here, but let's get into it. So what I'm going to do is here's John, and he's 1.7, and here is the shadow, which is 1.2, and then we're going to have building A. These will not be to scale. This is 104, and you could measure that, and so I'm going to put A in the middle here, and this is building B. This is not to scale, so we're estimating here. Just so that we can have something to look at. So I might even just call this A here and this B here, and we're trying to figure out how much taller is B than A. So basically what we need to do is keeping in mind that the sun creates the shadows, and the sun is so far away that would create what do you call them? Proportional triangles, similar triangles. So there'd be a multiplier from here to here, and there'd be a multiplier from here to here, and we could easily calculate that. So there's many strategies here, but one way would simply be 1.7 over 1.2 has to be the same as A over 104. Okay, and so we could cross multiply and divide by the 1.2 and figure out what A is. We could do the same with this guy here. Just a note, so if I do that, it would be the same as I could also go A over 1.7 has to be the same as 104 over 1.2. And notice that when I do my cross multiplication and divide by the part that's left over, it's actually the same as this guy. So those are the same. So bottom line is draw these really good pictures, make sure that we can make these connections, and then set up the proportion. And let's see what my PowerPoint looked like. So there's John, and there's his shadow. There's the real height, and there's 104. There's the real height, 239. And so these are some things. Corresponding angles are equal. People and buildings stand at 90 degrees. The sun's so far away that the angle of depression, and that would be this guy here, would be equal in all three. And if the two angles in the triangles are equal, then the third is equal. And so those would be things that we would know. And so we could see, I mean, here's also another way of considering this. And in this one, I just went, for the base, I went 239 minus 104, which is the difference between the shadows lengths. And then I went the real red height and the real green height, and I subtracted those. So basically, this is the change in height over the change in shadow. So that can also work. And so that's what I did. And then I would have just cross multiplied here and divided by what's left over. So it's kind of nice there to have a different solution. Okay, so here's another problem. Pause the video, do this on your own. If you're somebody who's just waiting for my voice and my solution here, you're not practicing problem solving. Now, that's not to say that sometimes you need to do that. Sometimes that's what you do need to do. But please note that that's not problem solving. That's just, that's sort of following the leader. That's trying to mimic or copy what I am doing rather than to create your own solution. So you have to decide where you are at and what kind of learner you're hoping to be and how you're hoping to grow. There is definitely a time to follow the leader, and definitely a time to copy and to mimic. And yet what we're trying to do here is practice your curiosity, your wonder, your creativity. So let's see if we can do that here. Jared slides down a fireman's pole, runs 3 meters east, and then walks 6 meters north. How far away from the top of the pole is he? Whew. You need to draw this really well. So let me see here. Okay. So we've got Jared, and he slides down. He's sliding down a pole. Slides down a 22-meter fireman's pole. That sounds very high. That's Jordan. Okay, and then he runs 3 meters east. 3 meters east, and then he runs. Then he walks 6 meters north. I'm not sure about my compass here, how I laid that out. So I'm gonna. This is a really difficult one to visualize. There's basically 3-dimensional. There's a down. There's a he moved east and then he moved north. This is not a great drawing, and I'm gonna leave this be as my first draft, and then kind of correct my image as I go along. But I'm going to do this. I don't know if this will help you visualize this or not, but I'm going to try to make this a 3D image so that I can get a better sense of what's happening here. Then if you're able to make this connection, and then we're wondering how far away is Jordan from where he first started, well, all of a sudden this question became a heck of a lot easier, because it's really just the diagonal of a rectangular prism. So if I called that d squared would equal the height squared plus east squared plus north squared. And if I take the square root of that, it would end up being 22 squared plus 6 squared plus 3 squared equals da da da. Now, friends, I'm going to make this seem so easy. I'm not problem solving right now. I made up this question, so I knew what I was doing. So if you're not wrestling with this for a good 10-15 minutes, you're not really problem solving. You're just copying it, and it will seem simple. So then when we give you different problems, you just won't be able to do it because you're not used to pushing in. So just be so careful of that. I'm just wondering if I could make this drawing a bit better, and that might be to put a north and put a south, and west and east. And I'm just wondering if there would have been a better way to draw that. Maybe, yeah, kind of tricky. I don't know about that. I would think I would just call this an estimation for now, and or I just spin. If I rotated the box, I could perhaps make this a bit of a better drawing. I'm curious though. If this is Jordan going down, and then we need to go east, which is, yeah, my drawing is not great. Maybe that would be north. Might be back that way, perhaps. I don't know. Either way, you could still end up doing it. You could still, make a rectangle. So anyway, so if this was east and this was north, that might be better. That would be a better way to think about it. The result would still, of course, be the same, because we're just trying to find out here. And this is where I'm using my curricular competencies of recognizing there's a number of ways of thinking about it, and being able to see these drawings in beside each other and decide which way works best for my solution. Okay, so there's east, there's north. I guess maybe that's maybe not. That might be a better way to do it. If you look back at my last drawings, this is probably a better way. And then when we just find that distance, we just know that we're going to use those formulas there, and there we go. So let's look at another problem. So again, I don't want you to be discouraged if you had to watch the last video and not try it on your own. Try this one on your own. So we're just trying to grow in and develop problem solving skills. Determine the length of the diagonal of a cube whose surface area is 294. Okay, wow, that sounds tricky. A cube whose surface area is 294. Well, we better start off with a good drawing here. So let's first off draw a cube. And this is already off to a very shocking start. I'm drawing with a mouse. You'll draw with a pencil, so yours will be better. So the surface area here, the surface area equals 294. And it's a cube, so all these side lengths are the same. Okay, so that's important. I'm going to draw the net for, well, I guess if it's a net, that means that all these would be the same. So each of these things here would be x squared. Oh, and there's 6 faces, so that means that it's going to be 6x squared equals 294. And so that's what I'm going to do to find the x. And I'm going to use my PowerPoint on the next slide here to help me with these calculations. Okay, so there we go. There's my picture, there's my net, and there's my 6x squared. We're going to find out that x equals 7. And so now when we know x is 7, we've recently learned a formula that tells us that d squared, so from here to this corner right here, is going to equal the square root of x squared plus x squared plus x squared. And you know how to fill that all in, and you know how to use a calculator. It's not d squared, it'll be d. And there you go. So I hope that you did that picture on your own and you're able to get down to x equals 7 on your own without watching this PowerPoint. And so this is a great place to end. And how do you think you're doing drawing pictures meaningful to represent pictures? In the next 3 sections in this chapter, it's all drawing. It is all reading contextual situations and finding solutions. And so you really, really want to be pushing toward taking the time to draw a fantastic picture before you try to answer the question. Okay, so I think that's where we will end. Take some time right now to report on how you're doing right now, and you might feel that you're developing, that you don't do it, you're not doing this well, or you're still working on it, or you need help or prompts. You might be emerging, so put that in your digital portfolio so that you can show your improvement over time. Okay, so we're going to end the video right there. I wish you well. Good luck.